Hey guys, alright, we're gonna start with 4.2. The title of 4.2 is the real zeros of a polynomial function, okay? So I got a few different color pens and erasers and markers and pencils. We're gonna need a highlighter just because we're gonna be highlighting a lot of important key concept and vocabulary. So, vocab, here we go, okay? I have 1, 2, 3, 4, 5 divided by 2. Some numbers that I made up. So 12,345 divided by 2. And then in elementary school, we learned that we divide it this way, right? So our answer is 6,172 with the remainder of 1, so we put it over 2. Basic. Nothing special. So let's talk about the vocabulary of elementary school division problem. In elementary school, we call this the dividend. Okay? We call the 2 the divisor. Now, when we put it this way, when we divide it this way, it's still the same thing. This is still called the dividend. It doesn't really change. The name doesn't change, even though it's in the different place. This is still called the divisor. Now this right here is your quotient. Okay. Quotient is the answer to a division problem, and this answer happened to have a remainder. So this 1 is your remainder. Okay. And again, the remainder is always placed over your divisor. So remember these words that your elementary school teacher used, hopefully. So now that we are in pre-calculus and we're doing dividing, okay, we're dividing polynomials, we are still going to use the same words, okay, but just kind of in a different way. Our equations, they look different. So here we go. Let's focus on the first box here. We have a lot of theorems today. It's kind of our notes today is kind of boring. So, but please listen because even if it's boring, the concept is so important. All right. Before I dive right into highlighting a bunch of stuff, I want to dedicate this video. I want to dedicate this video to all my country fans, right? If you love country music, this is for you. All right, here we go. Division algorithm for polynomials. It says, division algorithm for polynomials if f of x and g of x denotes polynomial functions. Okay, that means they're two different polynomial functions. And if g of x is a polynomial whose degree is greater than 0, then there are unique polynomial functions q of x, which is the answer, and r of x such that, so r of x is going to be our remainder function such that. So here we go. I'm taking my f of x, which is, and then I'm going to divide another polynomial, g of x. These are just two polynomials dividing each other. This is on the top, so remember we call this the dividend. Okay? This is on the bottom, so we call this the divisor. Okay? When we divide them, we get a thing called the answer, and the answer to a division problem is called a quotient. And we also have a remainder, and sometimes we do and sometimes we don't. So here's our remainder. Okay? And our remainder is always over our divisor. Okay? So that's all the same. Okay? Now, let's talk about what this is. So if we have an answer, okay, so I'm going to write some basic math up on the top. 5 divided by 2. Okay. We have an answer of 2 and a half. No big deal. We all know that. Now, if I want to get back to 5 and a half, what I do is I multiply these, right? 2 times 2. Okay, and then I add this. Would you agree with that? So 2 times 2 plus 1. That's going to be 5. And then again, we put it over our divisor, so it's 2. So I can go from This is called a mixed fraction to an improper fraction by doing this, times and add. Well, same thing. This is a mix, okay, this is a mixed fraction here. I can go from a mixed fraction back to my original by taking my g of x multiplied to my quotient. See what they did here? G of x multiplied to quotient. And add my remainder to get back my original. And that's all we do. Okay? So and then it spells out, okay, your r of x is your remainder, your denominator. And they don't have to use g of x. They can use q of x and w of x, whatever it is. The denominator is always going to be your divisor. The numerator is always going to be called the dividend. The answer to a division problem, it's always going to be called the quotient. Okay? Now, it also says here, the remainder, look at this right here. The remainder is either the zero of the polynomial or a polynomial of degree less than that of g of x. So if you have a remainder, so what that says is, if you have a remainder, it cannot be larger than your divisor. That's what it says here. If you have a remainder, your degree must be less than your divisor, which is that. Okay? Okay, remainder theorem. We're moving on up. Here you go. Remainder theorem says, let f be a polynomial function if f of x is divided by something called x minus c, then the remainder is f of c. Okay, what on earth does that mean? So let's give you an f of x, okay? Let's see, I'm going to make up something. F of x equals x squared minus, let's see, minus 2x and then plus 3, like that. Okay, so there's my made up polynomial. And it says here, here's my polynomial. If f of x is divided by x minus c. Okay, well, I want you to divide x minus 3. Okay, then the remainder is f of c. So let's look at it. Okay, let's divide. Here we go, long division, x minus 3. And if you don't remember long division, this is a great review for you. X squared minus 2x plus 3. So what we're going to do is going to take x squared, we're going to divide it by x. So what we're going to do is take the first term divided by that very first term. X squared divided by x is going to be x. Okay? Once you have gotten something on the top, you multiply it back. X times x is x squared. X times negative 3 is negative 3x. Okay? Well, but this is not it. Once you have written something here, you go in and you change your sign. If it used to be a plus, you change to negative. If it used to be negative, you change your plus. So now you combine them. The first two terms will always cancel. Okay, so now I have a negative 2 and a positive 3x. I'm going to end up with a positive x. Bring down my positive 3. Okay, let's see if this works. You know what? Since this is not going to work, let's change it to negative 3. How about that? Sorry, I just made this up, so don't. Okay, just negative 3. Did that bring down negative 3? I just want to make it a nice number. So a negative 3, we're going to have an x minus 3 divided by an x minus 3. So take this first term, divided by that first term, x divided by x, it's a positive 1. So write positive 1. Okay, so 1 times x is a positive x. 1 times a negative 3 is a negative 3. But remember, you got to go in and change your signs. Okay, so those two will cancel. A negative 3 and a positive 3 will cancel. Therefore, I have a remainder of 0. No remainder at all. Okay, so when I divide these two, my answer, my quotient, this is my quotient, it's x plus 1. Okay, with no remainder. No remainder. Alright, so now, what does this have to do with this? Okay, well, it says here, let f be a polynomial of f of x. when I divide it by x minus c, in this case, my x minus c happened to be this, okay? Let me zoom out. Okay, x minus c happened to be this. Then the remainder is f of c. Okay, well, if this is x minus c, then c must be 3. Would you agree? Okay, if this is f minus c, just like this is x minus c, then c has to be 3. Well, how does that work? F of 3. It says then my remainder is f of 3. Well, let's see if that works or not. 3 squared is 9 minus 2 times 3, which is 6. Bring over my negative 3. 9 minus 6 is going to give me, what is that? 3. So f of 3 equals 3. 3 minus 3 is 0. Oh my goodness. Okay, so the remainder is 0, which is exactly what we have. Okay, so if you just want to find the remainder, it's a lot easier to plug in your c value into the equation than doing long division. Wouldn't you agree? So knowing this theorem is so useful if all you're looking for is the remainder. You got it? Okay. All right, moving on to factor theorem. Factor theorem. Let me just zoom in a little bit here just to fit. Okay. Let f be a polynomial function, then x minus c is a factor of f of x if and only if f of c equals to 0. Okay, let's read that one more time. Let f be a polynomial function, then x minus c is a factor of f if and only if f of c equals 0. That is related to this theorem. These two are related to each other. When I did this division over here by long division, okay, would you agree that when I took f of x divided by x minus 3, my remainder was 0. Okay? And when I did it this way, it was also 0. So we know we did it right. But it says here, hey, if your remainder is 0, okay, if your remainder is 0, then this piece right here is a factor. Okay, is that a true statement? Well, let's look. F of x equals x squared minus 2x minus 3. Okay, I have one quotient, which is x plus 1, and I have another factor, x minus 3. If I were to FOIL this back out, I would get this. So that's what it means. If you have a remainder 0, then this is a factor. Okay? In another word, this is just kind of going backwards, okay? If f of c is 0, then x minus c is a factor, which is the same thing, the same saying, right? If f of c is a factor of this function called f of x, then f of c is 0. So all of these right here is, all these 3 boxes is really stating the same thing, okay? So x minus c is a factor if f of c is 0. All right? Next one. Number of real zeros theorem. Okay, this means, let's read it, a polynomial function of a degree, something called n, if n is greater than or equal to 1, has at most n real zeros. So let's talk about this. F of x equals, let's do x to the 7th. I'm just kind of making up some numbers, okay? This means I have at most 7 real zeros, okay? That doesn't mean I have exactly 7 real zeros. I might have 1 real zero or 0, nothing at all, no real zeros at all, and all of it imaginary. But it's kind of different from turning points. Let me bring turning points back. Turning points, I have at most 6. Okay, so turning points always less, but real zeros 7. This again doesn't mean I will have all 7. I might have 7, 6, 5, 4, 3, 2, 1, or not at all. Okay, let's flip over to our next page. More vocabulary. All right, you know what? I'm just gonna stop right here and go to example 1. Let's find example 1. Okay, here we go. Alrighty then, here you go. Example 1. Use the remainder theorem to find the remainder when f of x is divided by x minus c. Then use the factor theorem to determine whether x minus c is a factor of f or not. So here we go. This is your x minus c. Can you guys see that right there? Okay. This is your x minus c. So c is -3. Okay? Because by definition it says x minus c. So for me to have an x minus, and -3 to give me a positive. So c is a -3, this piece. Okay? It says use the remainder theorem to find the remainder. So the remainder theorem said, hey, the remainder is 0. Okay, then it's a factor. So let's find the remainder. So f of -3 equals. Okay, whoops, moving over. Let's write everything down. 2 times -3 to the 6th minus, I'm going to do down here, okay, 18 times -3 to the 4th plus -3 squared and minus 9. Okay, let's do some basic math here. -3 to the 6th. Oof, that is a large number. So let me consult my my best friend called the calculator. All right, best friend, come give me a lifeline. Let's find it. I don't know where it is. So let me find it really quick. I let somebody borrow it earlier, and now I don't have it. All right, I guess cell phone it is. There we go. All right, cell phone. Calculator. All right, here we go. -3 to the 6th power. Sideways. Sorry, I just need exponent buttons. -3 to the 6th. I know I'm going to have an even answer, so let's do 3 to the 6th. So 3 caret, where's my caret? Where is this? I don't really use my cell phone. I have an issue. I don't know how to use my cell phone. I'm just going to multiply it 6 times. 1, 2, 3, 4, 5, 6. All right. Is that right? 2600? 2673? Let's do it again. You know what? Let me do it by hand. I don't trust my cell phone calculator. 2 times -3 to the 6. That means I have -3 6 times. That means I have 9 3 times. Okay, like that. Minus 18, -3 to the 4th. Ooh, it's turned orange all of a sudden? There you go. -3 to the 4th means I have 9 2 times, right? -3 squared, that means I have 9 1 time, minus 9. Ooh, that will cancel each other out. Here we go. Sorry, I don't know if my calculator, my cell phone was giving me the right answer, so I'm just going to do it by hand. This is going to be 18 times 81. This is going to be minus 18 times 81. And this is canceling each other out. Nice. Okay, look at that. By hand. Looks like it's even faster. All right, positive 18 times 81 minus 18 times 81. My remainder is, a 0. All right. So because my remainder is a 0, okay, use the remainder theorem to find the remainder. So remainder 0, okay. Then use the factor theorem to determine whether x minus c is a factor or not. Because the remainder is 0, this 3 dot means therefore. So if you're listening, this means therefore. Hence, as a result, x plus 3 is a factor of f of x. Awesome. Box that up. Okay. Isn't that cool? All right. Let's go and do example B. Okay. Example B. Here we go. Same thing. We're going to start with doing f of c. Okay. And again, c is going to be a -1/3. So let's write that out. F of a -1/3 equals 3 times -1/3 to the 4th power plus -1/3 to the 3rd power minus 3 times a -1/3 plus a 1 plus a 1. Can I fit it in there? Sure. That's a skinny one. Okay. Without my calculator, let's do this by hand. F of -1/3 equals 3 times. This is an even power, so I know I'll have a positive answer. negative 1/3 to the 4th, I'm going to have a positive 1/9 twice. Okay. Negative 1/3 to the 3rd power, I'm going to have a negative 1 over 27. Negative times a negative is a positive 1. And add a 1, so bring that down. So f of a negative 1/3 equals, I can reduce that, so 3 go into 9 3 times, so 1 over 9 times 1 over 3 is 1 over 27 minus 1 over 27 plus a 2. These two will cancel each other out, so now I have those will cancel. I'm going to end up with 2. Look at that, no calculator, way to go, right? So look at this, my remainder is 2. Okay. As a result, okay, because the remainder is not a 0, x plus 1/3 is not a factor of f of x. Okay. So, it's only a factor if you have a remainder of 0. Okay. Now, with that being done, let's flip over to our vocabulary. Excuse me. Okay. This is going to be our last one, okay? Actually, you know what? I'm going to stop right here. I'm going to let you guys take a break. But before I stop, I'm going to give you a joke because a lot of you have been requesting a joke here. So, let me try to think. What should I tell you? All right. What is a pirate's favorite fish? What is a pirate's favorite fish? A pirate's favorite fish is a swordfish. Ha ha ha. Get it? Pirate, they use swords, so they like swordfish. Okay, this is the end of today. Have a good one.